Subnet calculation is one of the basic skills that you need to master in your journey towards network proficiency. Remember that you can pause and replay this video as often as you need to. So, why do we need to be able to subnet? In your studies, you've learned about the need to segment networks. A large company may have several departments, and we can create a subnet or segment for each department. If the engineering department is sending a lot of data to computers within their own department, it doesn't affect the performance of the rest of the network. Each network segment needs to be its own subnet. The first thing we need is a block of IP addresses. Let's assume that we've been assigned a Class C address. A Class C address has a total of 256 possible hosts, which can be PCs, servers, printers, or even router interfaces. These host numbers range from 0 through 255. As you've learned, however, in a Class C address range, we can't use a 0 address. That's reserved for the network or wire. The network or wire address refers to all the IP addresses within the address range. The number 255 is reserved for the broadcast address. This address, for example, is used by ARP requests when a packet must be seen and processed by every host in the network or subnet. The subnet mask is used to indicate which bits are used for the network portion of the address and which bits are used for the host portion of the address. With the Class C address, the first 3 octets are reserved for the network portion of the address, and the last octet is reserved for the host portion of the address. A subnet mask is structured in the same manner as an IP address. Both are 32 bits long and are represented by 4 dotted octets. Let's look at the structure of a Class C subnet mask. The default Class C subnet mask is 255.255.255.0. If we write that number out in binary, 255 is represented by 8 ones, so we have 8 ones in the first octet, 8 ones in the second octet, 8 ones in the third octet, and 8 zeros in the fourth octet. Remember that the first octet is reserved for the network portion of the address, the second octet is the network portion, third octet is network portion, and the fourth octet is used for the host portion. Another way to express the subnet mask is to indicate how many binary digits are turned on. If we have 8 in the first octet, plus 8 in the second octet, and 8 in the third octet, we have 24 bits turned on, so we can represent that as a /24. Why do we need to know which bits are turned on in the subnet mask? Every bit that's turned on, or represented by a binary 1 in the subnet mask, is one of 2 possible things. It's either part of the network address or it's part of the subnet address. Every bit that's turned off, or represented by a binary 0, is part of the host portion of the address. We want to break up or subnet a Class C address into smaller blocks of addresses. Let's say that we were assigned the Class C address of 206.207.208.0. Remember, the default subnet mask for a Class C address is 255.255.255.0, and we can write that as /24. Here's our scenario. We have 4 offices located in 4 different cities. Each office has a maximum of 25 hosts or computers. We need to be able to subnet our Class C address to allow for this situation. Since the first 3 octets in the Class C address have been assigned to us, we can't change those values. Remember that the first 3 octets are reserved for the network portion of the address. There's an imaginary line separating the network portion of the address from the host portion of the address. In the next video, we'll start using this information to calculate our custom subnet mask.